Hello everyone, welcome to my channel. Today I am going to discuss about another new topic which is called Astronomical telescope. Till now we have discussed about simple microscope, compound microscope and problems related to compound microscope. Now we are going to discuss about astronomical telescope. What is the use of any telescope? Let it be terrestrial telescope, astronomical telescope, any telescope. What is the use? We basically use a telescope to see far objects, right? Which is almost like an infinity distance. We use the telescope to see stars or planets, right? So such kind of objects which are too far, like infinity distances, we are using it, right? So in astronomical telescope, we are using as like compound microscope, we are using two lenses. Of course, the lens which is near to the object is called objective lens, and the lens which is near to the eye is called eyepiece. But here, the object is at infinity distance, keep this point in your mind. Unlike compound microscope, in astronomical telescope, objective length, focal length as well as aperture is big. Why? What is the necessity to use a big aperture and more focal length? Because as the object is at infinity distance, the amount of light comes to us is very small and very less. Therefore, we have to capture as much as light possible. Therefore, we can get a clear image. Because of that, we use high aperture of the objective lens and small aperture and small focal length of the eyepiece. It is unlike compound microscope, because in compound microscope we use in the reverse order. So now listen now carefully. An object, as it is at infinity distance, the light rays which are coming from the object is parallel and which are fallen on the objective lens. The one light ray which is passing through the optical center, which is undeviated, and the other light ray which is passing through the lens and refracted, and these two refracted rays met at a point A. So according to the rule, if any two light rays are parallel with the principal axis, they will converge at the focus or on the focal plane. What is meant by focal plane? Focal plane is nothing but the line on the focal length. So this line is called focal plane, because if the two light rays are parallel with the principal axis, definitely they will meet at the focus on the principal axis. If two light rays are parallel but not parallel with the principal axis, they will converge at the focal plane but not on the principal axis. Remember this point. So finally we got the image at f0. Therefore, image distance is equal to focal length of the objective lens. Keep this point also in your mind. Now this image will act as an object to the eyepiece, and remember, as like compound microscope, the image length or the object distance from the eyepiece is lesser than the focal length of the eyepiece. Therefore, you will get a virtual, enlarged and highly magnified image in front of the lens, right? So if you want to see an object clearly, if the image is formed at near point, the least distant the image should form is least distinct vision, right? There are two cases as like in the previous lectures, near point and far point. For near point, the image at least must be formed at d distance, and the far point the image will be formed at infinity distance. Of course, we will discuss about these two cases again. So let me write. So if you observe the ray diagram, the light ray which is falling through the optical center have made an angle alpha. So this alpha is nothing but angular width of an object. Alpha is nothing but angular width of an object. So let me write that. Angular width of an object. How you will calculate? From triangle OF0A, if you look at, angular width of an object alpha is equals to h by f0. h by f0. Now this image will act as an object to the eyepiece. Finally you will get an image at BB dash. It is highly magnified, so you see through it. Therefore, the angular width of an image is beta. If you look at the triangle B, B dash, where beta is the angular width. If you observe, there are two similar triangles. Triangle OF0 A is similar with triangle OB B dash. See, OF0 A is similar with OB B dash. Therefore, what is the angular width of an image now? Angular width of an image beta is equals to, we can write either h dash by least distinction or h by u. H by u, object distance for the eyepiece. Keep it as 2. Therefore, I am talking for near point. That means if the image is formed at near point, that means least distinction. Therefore, magnification produced by the astronomical telescope when the final image formed at a near point is equals to angular width of an image by angular width of an object. Right? So, what is angular width of an image? H by UE. What is angular width of an object? H by F0. Therefore, what you will get it if you simplify? H will get cancelled, F0 will goes up. Remember, here object distance is negative. Sorry, I forgot to write it. Object distance is negative. So you will get this is what the magnification produced by the astronomical telescope in terms of focal length of the object to lens and object distance from the eyepiece. If you wanted to know in terms of focal length of the eyepiece, this we can modify as, let us look about this diagram now. The object distance for the eyepiece is minus UE, focal length of the eyepiece is plus FE, and distance of an image from the eyepiece is minus D, because I am talking about near point. Substitute these values in the lens formula. 1 by F is equals to 1 by V minus 1 by U. What do you will get it? 1 by FE is equals to 1 by minus D plus 1 by UE, because minus of minus plus U. Therefore, calculate UE value, send this side. What you will get it? 1 by UE is equals to 1 by FE plus 1 by D. Therefore, UE is equals to FED by D plus FE. Substitute this in the given equation. This is minus. Therefore, magnification produced at the near point is equals to minus F0 into D plus FE by FED, or magnification produced at the near point is equals to minus F0 by FE if you take common, 1 plus FE by D. This is what the magnification you will get it for near point. What about for far point? I will write here far point. Far point means what? Image distance will be at infinity. The final image formed by the eyepiece will be at infinity. That means D value will be infinity over here now. This formula only we can modify it as like magnification produced at the infinity distance is equal to minus F0 by Fe into 1 plus Fe by infinity. So finally what you will get it? Minus F0 by Fe, 1 plus Fe by infinity, this value is 0, 0 plus 1 into 1. Therefore, final magnification produced by the astronomical telescope, if the final image is formed at infinity distance, this is what the formula. If it is near point, this is what the formula. I hope this lecture is useful to you. If you have not gone through previous lectures, please go through it.